Welcome to video 3, summation and sigma notation. We're going to be introducing sigma notation. Some of you may have seen this. You can see the symbol right here on the first page. We're going to describe a series using sigma notation. We're going to introduce some basic summation rules and evaluate functions. All right, just a reminder, a sequence that we learned in the first video was something like the Fibonacci sequence, where we were just listing terms and we would continue listing. But a series is where we would actually add the terms together. Sorry, 3 and then 4. And so you would actually add those. So 7 plus 3 is 10. So this sigma notation that we're talking about here, this is the symbol, Greek symbol, sigma. Sigma means to sum up. So the notation here, where we're using an awful lot of letters, the J equals 1, it says to add the scores, or whatever we're going to do, this is going to be the rule. So this is the rule. Where to start would be, this tells me the number where to start. I'm going to start with 1. And then the stop number would be n. So to write this out, I would say x sub 1 is my first, plus x sub 2, plus x sub 3, plus, and then eventually I'm going to get to the ending number, which would be n. So for instance, on this rule that I have right here, this says I want to sum up using this rule, and I'm going to start n at 1, and I'm going to end after 3. So when I go to write this out, I'm going to say 2 times 1 plus 2 times 2 plus 2 times 3. That's going to give me 2 plus 4 plus 3, which is 9. So this whole thing right here would be equal to 9. This idea of adding areas together are what we're going to use in calculus later on when we find the area under a curve. We found the area under two-dimensional, kind of straight curves and things, straight. But in calculus, we would actually have different areas, and you can see them here, all these different areas. So what I want to do is I want to add a sub 1 plus the area of the second region, the third region, the fourth region, etc., the fifth region, right? So instead of writing them as individual sums, I can say I want to add all the sums, the area, right, a sub n, where n is 1, and then I want to end after 6. And so these would be equivalent. So the sigma notation for a series, it says show the summation of the first through fifth terms of this sequence. So the first through fifth term of this sequence would be, this actual whole thing would go from 1 to 10, right? But I just want to go from 1 to 5, and if I wrote it all the way out, I would say a sub 1 plus a sub 2 plus a sub 3. If I wrote the whole thing out, I'll do the first 5, but then I'll show you how you do all 10. If you don't want to write them all the way out, you can do that. A sub 10, and that would be all the way to the end. First through 5 terms of this next one would be a sub 1 plus a sub 2 plus a sub 3, just like what you're saying, a sub 4, a sub 5. Now this one has an actual answer. This one you can't, the first two you can't add them together. There is no a sub whatever. But this one, I'm going to let n be 0 first. And I'm going to stop at where n is 4. So here's 1 and 2, 3, 4. And I wrote them all out because I want you to see that from 0 to 4 is 5 terms. If I go from 1 to 5, 1, 2, 3, 4, that's 5 terms. So the starting number is going to tell you how many terms. You have to be careful, because if you wanted 5 terms, but you said 0 to 5, you're going to get 6 terms. Okay, so this is 0 plus 2 plus 4 plus 6 plus 8. This is 10, so is this, so this equals 20. All right, it's one thing to use the sigma notation to write out the terms. Now what we want to do is we have the terms and we want to write the summation using the summation notation, the sigma notation. All right, so we're going to start off with writing sigma, and it says we want to use sigma notation to represent 2, 4, 6, 8, for 45 terms. So I know that if I let n equals 1 and go to 45, that's going to give me 45 terms. And then I need to come up with a rule. So if n is 1, to get a 2, I would do 2 times n. Now you want to always check, because it's possible that that isn't going to actually get you the first term, and you have to do a little bit of extra. So I have 2, if n is 1, I have 2, if n is 2, I have 4, if n is 3, I have 6, and that looks like that works. So that's my rule. For this one, it's real similar, right? If I want to do 50 terms, I start at 1. Generally, you're going to start at 1, unless you have to kind of play with it for your formula, and then you want to go to 50. All right, so to get 3, 6, 9, 12, 15, I know I'm going to take 3 times n, right? Now, my first thought on this was that I would do negative 3 times n, right? That would get me a negative 3 for the first term. But then if I put in a 2, I'm going to get negative 6, and that's not right. So I have to alternate the signs, and we've talked about this before. So I'm going to multiply negative 1, and I'm going to put it to the n power. Now, if n is an odd number, this is going to be negative. And if n is an even number, right, a negative times a negative is a positive, so then that would be a positive. So let's see if it works. So if n equals 1, I'm going to put 1 in for n, and that would be negative. At n is 2, I'm going to put that in there, and it's going to be squared. If n is 3, that would be negative, and so this alternates the sign. So this whole thing is the rule, and it's going to go from 1 to 50. All right, this last one down here, we're going to use the summation notation, and it's written in such a way that you can kind of see the parts, right? So I'm looking here, and I'm going to go from 6 to 31. 6 to 31. There might be an alternate way of doing this, but I'm going to use K just to shake it up a bit. And let's say I'm going to go 6 to 31 and see if that works. And then I want to look at things that don't change in each one of the terms. If they don't change, they don't get a variable. So I'm going to write my rule. There is going to be a 5, and there is going to be a plus 3. And then this number here, I could put as K. And then I check. K is 6. There's a 5, 6. K is 7. K is 8. K is 9. K is 10. And it goes all the way to 31. This one works. I have a question for you. Does that work? Is that the same thing? Here are some strategies that I would like for you to look at. They're really helpful when you're having to write partial sums. It shows you to see the patterns in the numbers and see how that relates to a formula. I found those really helpful, and that's why I put it on here. Most of the time, when you have a small group of numbers that you're finding the sum, like you just want 1 to 5, 1 to 8, then it's just as easy to write them out and add them up. However, if you had a summation where you needed to add up 45 terms or 50 terms, it would be really tedious to write them all out and to add them up, even with a calculator. So what I would like for you to do is look at some of these rules for summation. All right. For instance, this first rule, C is a constant. C is a constant. Okay. So it says go from 1 to 3, and the rule is just 2. There's nothing to plug in. So I would do 2 plus 2 plus 2. 1, 2, 3. The answer is 6. Right? So if you'll notice, 3 times 2 is 6, and that's the rule. So if I had 200, K equals 1 of 3, the answer would be 3 times 200, or 600. That's the easiest rule. Okay, on number 2, the rule number 2 is if you have a constant times one of these things, the constant will come to the outside. So for instance, on this one it goes from 1 to 3 of 4n. It would be the same thing as 4 times the sigma of n equals 1 to 3 of n. If I were writing this out, I would have 4 times 1 plus 4 times 2 plus 4 times 3, right? And then add it up. Or I would have 4 times 1 plus 2 plus 3. And so the same thing is going to be, if I did it right, 24. So basically you can take the constant out, find the variable, and then multiply back times the constant. Here are a couple of other rules. All this really says is that if you're given something that looks like this, where you've got a quadratic, a linear, and a constant term, you can actually split them up into 3 separate ones. So for instance, this one is the constant rule, so that would just be negative 15. This one is going to have a formula that's coming up here in a minute, and so is this one. So you could do this, this, and then add them all up and get a sum, and that's how you do them separately. You can also split, this is the starting number, so from 1 to 6, so instead go 1 to 3 and then 4 to 6. So you can actually split that number, the starting and stopping values. So here is the formula. If this is just a constant, a linear term, just a linear term, you would use this. And notice that it is, the n is the stopping number. So for your rule then, what I have here, I actually have 2 things. I have a linear term and a constant. So I'm going to separate it, and I'm going to say the sigma of j equals 1 to 20 of 3j plus the sigma of j equals 1 to 20 of 2. You can see how I've got it separated. This is really easy. This last one is really easy. It's just plus 2 times 20, right? That's how I do that one. This one is going to be 3 times, because the constant can come out, and then this linear is going to be n times n plus 1 over 2. Well, what is n? N is 20, so I'm going to have 20 times 21 over 2. And once I have this, then the rest is just doing the math. So this is 10, so I'm going to have 30 times 21, 630, so I have 670. Okay, these are the last 2. I would like for you to work these for homework. I do want to get you started so that you can see how they are set up, and then I'd like for you to finish them before class and get the answer from me when you get there. Okay, so let's talk about this one. This first one is got a linear and a constant, so I'm going to rewrite I equals 1 to 5. This is 2i, so this is an I, and I'm going to write the 2 outside, plus, and then the last one is from I equals 1 to 5 of 5, and you're going to solve that. All right, down here, I'm going to rewrite it. It has 2 terms. So I'm going to have I equals 1 to 30 of I squared minus I equals 1 to 30 of I. All right, so you're going to use the formula. Both on this one, n is 30, and on this one, n is equal to 5. So see if you can get the answer, and I will see you in class.